Hi everyone, this is the second part of lesson 7.7 and 7.8 with the rational exponents. I did decide to split the video into two parts just because the first part got a little long. So this is just focusing on examples 3 and 4, which if you'll notice deal with simplifying and solving, okay? And what you see here that you didn't see on the previous page is all kinds of letters and variables. We've done a bunch of problems that look like this, okay? We've never done them with the fraction exponents, but all the rules still apply. So we're trying to raise this entire thing to the power of 6. I'm going to split this because remember each one of these pieces kind of operates by itself. I'm going to go 2 to the 6th power, okay? 2 to the 6th power is 64. You can check that in a calculator if you need to. And then when I'm raising a power to a power, I'm multiplying. So I want to do 1/2 times 6, which is 3. And so then that's going to become a to the 3rd. And then here, negative 2/3 times 6. Notice, I don't even care about the negative. Let's see, that'd be negative 12 over 3, which is negative 4. And so then I get b to the negative 4. And then just remember, I can't leave negatives in my answer, right? So I didn't care about the negatives a second ago. I just did the math like I normally would. But now I'm going to take this b and move it down underneath. So that's going to become 64 a to the 3rd over b to the 4th as a final answer. Okay? Next one's a division problem, right? So I'm going to split it and split it and split it. I'm going to set up my fraction bar so that I know where things go. Okay, 12 divided by negative 3 makes a negative 4, but that's not a negative exponent, right? That doesn't make a negative exponent. So my negative 4 is still going up on the top. Because remember, if I put that negative 4 on the bottom, that's really saying it's equal to 1/4 instead of 4, right? Putting a 4 on the bottom is the equivalent of having 1/4, and 12 over 3 is not equal to 1/4. Okay? All right, so my subtraction rule, my division rule is that I need to subtract. So next up, I'm doing 3/5 minus 2/5, and I get 1/5. And so then that would leave me with x to the 1/5, and that's positive, so it's going on the top. For my next one, I need to do 1/3 minus 5/4. Now, this may require a little bit of a fraction refresher for some of you. Remember that when you're adding and subtracting fractions, you do need a common denominator, okay? So I want to turn these both into something over 12. Okay, because 12 would be a common denominator between 3 and 4. Let's see, I would have to multiply by 4, so then this would become 4 over 12. Here I would have to multiply by 3, so this becomes 15 over 12. Okay, 4 over 12 minus 15 over 12. That's going to make negative 11 over 12. 4 minus 15, negative 11. And then so that's really y to the power of negative 11 over 12. If it's negative, that means it's going downstairs. So it's going to end up like this. Okay. If you had wanted to, you could have done it like this one where you just wrote them all out without putting it in a fraction and then just moved the stuff that was negative in a second step. But usually when it starts out as a fraction, I go ahead and set it up as a fraction. All right. And conversely, you could have done this one that same way. You could have started with a fraction bar and just when that came out negative, known to put it on the bottom. Okay, so sometimes I go this way, sometimes I go this way. I really don't have a good rhyme or reason. Okay. Okay, so again, wrap your head around that. We just followed the same rules we always have. We just had to do some tricky things when you had to subtract with fractions. All right. If you have the benefit of the calculator at the moment, you could always just type this into your calculator. Just make sure you turn it back into a fraction. So that would look like this. 1/3 minus 5/4. Just type it in with division. It's going to give you a decimal back. You don't want to put decimals in your answer. But if you hit math and then that very first one is fraction, there's your negative 11 over 12. Okay, so that's if you have the calculator available to you. Again, I would say something like this is fair game to be asked of you without a calculator. Okay, so make sure that you follow how to do those even if you don't have a calculator. Okay, on to example 4. We're doing some solving here. All right, so first thing to get rid of is anything that's being like added, subtracted, multiplied, divided. This first example doesn't have any of that. It's just a power, right? But if I did have like x to the 5, 6 plus 7 or something, I would get rid of that other number first, okay? So I want to think about how can I get rid of a power of 5, 6? And we sort of talked about this yesterday, although I hope you made the connection because it was only powers with 1 on the top, that really what we can do here is raise to the power of the reciprocal. Now notice I said raise to the power and not multiply, because when I raise to a power, these two end up getting multiplied together and they cancel each other out. But this is an exponent, right? So over here when I do it, I want to make sure I'm going to the power of 6 over 5, okay? I'm not doing 32 times 6 over 5. I'm raising to the power. Okay, so this is going to cancel out now, right? So we'll just have x equals. Now we need to figure out what this thing equals. And again, I'm going to go devil's advocate here and pretend we don't have a calculator available to us, okay? Because we could put that in a calculator. But I'm going to do this just like I did in the first part of this lesson. I'm going to go 32 to the 1/5, okay? And then raise that to the power of 6. Okay, so 32 to the 1/5 is equal to 2, and then 2 to the 6th. 2 to the 6th would be equal to 64. So then my answer is x equals 64. Okay? Okay, so on that next one, first thing I'm going to want to do is get rid of that 4. I can't do anything until I'm with the power until I'm down to the point where all I have is x to the power left. So I'm going to divide by 4. This may freak you out right here, the 4/9 divided by 4, but I want you to think about this practically. If you have 4 of something, you have 4/9, all right, and you divide it by 4, what you're going to have left is 1/9, all right? 4/9, you have 4 of something, you have 4/9, and then you divide it by 4, so you're going to have 1 of those remaining. And then, let's see, this would be x to the negative 2/3 equals 1/9. Okay, so now to get rid of this, I'm going to raise to the power of the reciprocal, but I do want to make it negative, okay, because the two negatives will cancel each other out as well. So the 3/2, the 2/3, those cancel, and the negative cancel. So over here, I want to go to the power of negative 3/2. These are gone now. Now I just need to figure out what the heck this equals, right? So again, I'm going to take this and split it, all right, into multiple powers. And this is another one. I know I'm going to have to flip this over eventually. And since this is a fraction right now, I might want to go ahead and flip it to begin with. So I'm going to set it up as 1/9 to the power of negative 1, and then the fraction, and then the power of 3. Okay? So focus first on this. 1/9, the negative 1. That flips it over and makes it a 9/1, otherwise known as just 9. Okay? 9 to the 1/2, that's like the square root of 9, so that's going to be 3. 3 to the 3rd, and 3 to the 3rd is 27. So what we really end up with here is x equals 27. If you wanted to check and see that you were correct, now that's only going to work if you have a calculator handy, but if you wanted to check, you would do 4 times 27 to the power of negative 2/3. So I just typed in the left-hand side of the equation there, okay? It should equal 4/9. Oh, that's crazy, but let's hit math and fraction, and sure enough, that's equal to 4/9, okay? So really the big key here is, first of all, eliminating any other numbers that are there with the x, okay? Once you're down to just a power of x, you raise to the power of the reciprocal. And to actually calculate that power, that's where you go back to what we did on the first page and do all the splitting, okay? Unless you have a calculator available, and then you could just type in 1/9 to the negative 3/2, and it would give you 27, okay? But again, I really want to emphasize that whenever you can go without a calculator, you should do it, because it is important that you know how to do these calculator free, okay? Okay, that's it for this lesson. We are going to practice this for the next couple of days, and then you have a quiz, I believe, on Friday over this stuff. So good luck, and we'll talk about this more in class tomorrow.